Okay, so this is just a quick presentation on how the whole Project 2 works. I kind of have it represented visually. The two clients are on the left side. The mediator, the name server, is in the center, which would link it up to the main two math servers. So we start up the name server, and as you can see right off the bat, it's failing to connect to the servers, obviously, since they haven't started yet. And you know, if we want to, we can go in and start a client here to connect to the name server, and immediately, you know, they'll get the address, they'll get the no servers, which is basically if this guy has failure on both servers, it sends no service to the client, and the client gets kicked off. But then you start up one of these servers here on any port. It's just specified in the code. And right off the bat, you can see that the name server updates success on connecting to server, and this is just a visualization to show that the name server is constantly connecting. I gave it about a 5-second sleep time between them, just so that you're not creating too much traffic between the two. And let's go ahead and run a client, and as you can see, it's a lot of output here, but the client checks the name server right off the bat, finds the initial server connection is to the main server, and then it starts its thread. It has a thread that runs in the background to always update the global connection in case if one of the servers goes down. It's constantly reading from the name server to get the most up-to-date version, which server to connect to, so that when you're sitting here at this prompt, you know, which is a blocking call, it's still going through with the thread and checking the servers. So we'll just go ahead and do a math problem here, and as you can see, it goes to the main server, which is up, and all the math is correct. And what the name server here is showing is just the status of both. Whenever it's always checking the status, which is an array within the name server, and based on the values in the array, it sends back the name of the right server to connect to. So the client never has the array in itself, because that would just be, you know, bad for security, things like that. All it has is the name of the host. So we'll go ahead and start up the second server on the same port, and right off the bat, name server is connecting. It says success on both the backup and the normal server. And what we can do here is we can actually take down the main server now that the backup's on, and you'll see right away the name server realizes it's down, and then it updates the client to realize that it's also down. So now if we perform math on this client here, you'll see that it goes to the backup instead. And also, just one of the last requirements, whenever you start back up the main server, the name server reads that it's back up, and hopefully in a second here, after the 5-second period, it'll update to where its host name is back to being the main host name. Oops, do some more math, and as you can see, it requests the main server instead of the backup, just to show that it has the ability to host more than one. Go ahead and do another client here, which goes to the main server. So yeah, each of these guys, the client has, you know, the regular interface for creating the math opcode to send to the server, as well as the thread running in the background constantly in the heartbeat with the name server, constantly getting the updates. And then the name server is the thread, not only with the client, but with the regular two servers here, checking them too to make sure that they're online. And then once you make this link, then, you know, you can communicate back and forth between the two. And the server has a thread as well, so that you're not so that you can constantly have the name server checking it, so that you're not blocking the client from connecting. You've got one thread that handles this connection, and then the regular main thread that handles the connection between these two.